All right, good day, everyone. Hello, my name is Riley Edwards. I'd like to welcome you all to the virtual William W. Hay Railroad Engineering Seminar today. Before I introduce our speaker, I want to remind listeners that you can ask questions of our speaker by typing them into the question box on the side of your screen. I will then relay them to the speaker at the appropriate time in today's seminar. The William W. Hay Railroad Engineering Seminar Series is sponsored by the Rail Transportation and Engineering Center here at the University of Illinois. On behalf of all of us in Railtech, we thank the Association of American Railroads, BNSF, CN, Hanson Professional Services, and Union Pacific for their ongoing support of Railtech. It's greatly appreciated by all of us here on campus and those of you that are participating today via the internet. I'd like to extend a welcome to the more than 300 people from 10 countries who have registered for today's seminar, one of our largest attendance to date, if not the largest. This list includes representatives from freight and passenger railroads, transit organizations, federal and state DOTs, engineering firms, universities, research organizations, suppliers, and others. We're pleased that you can join us, and I know that our presentation today by Mr. Wolf will be quite interesting. Those of you that wish to receive PDHs for your participation, please send us an email at heyseminar@illinois.edu with your information that was described in the email announcement you received. We've got a few more seminars this semester, and we'll talk about those a little bit later after today's seminar. You can visit our website for more details. So I'll give you a brief abstract for today's presentation. The safe and efficient movement of goods and people is the primary objective of railroads that make up our U.S. rail transportation system. Continued technological advances and opportunities for their adoption abound, and many are being implemented by today's railroads. Despite these advancements, and after a multi-decade decline, derailment rates have generally remained stagnant over the past decade. What should railroaders, regulators, and investigators do in this era of PSR to bring our derailment rates under 1 per million train miles? Today's presentation is going to cover a variety of topics and timely recommendations for stakeholders as they battle to further reduce derailments. Our speaker is going to focus on track, human factors, equipment, and management topics today. And he's warned us that this may be an exciting presentation that may ruffle some feathers. I want to introduce today's speaker. He's no stranger to the rail industry. Many of you have known him for years. Our speaker is Mr. Gary Wolf. Mr. Wolf has over 50 years of experience in the rail industry, including 17 years at the Southern and Norfolk Southern Railway, 26 years as a consultant and owner of Rail Sciences, and the last 7 years in private consulting practice. He began his career in 1970 in the mechanical engineering department, the Southern Railway, but since 1975, he's focused on the analysis and prevention of derailments. He has investigated over 4,000 derailments and trained over 5,000 railway professionals in the techniques of derailment investigation. He also practices in the area of train operations, testing and instrumentation, vehicle dynamics, wheel-rail interface topics, track maintenance, and its assessment. Mr. Wolf has a bachelor's degree in science and electrical engineering from Ohio University and a master's of science from Georgia Tech in industrial management. He's a member of ASME, AREMA, the Air Brake Association, and IROR, and the International Association of Railway Operating Officers. And now I'd like to allow Mr. Wolf to give his presentation titled Essential Strategies for Derailment Elimination in Today's PSR Environment. Welcome, Gary.
Thank you, Riley. Welcome, everybody. If anyone has trouble hearing me, let Mr. Edwards know. Hopefully our sound is going to be okay. The reason for this presentation is threefold primarily. One, Riley's already mentioned, and that's my frustration of the fact that for the past 10 to 12 years, our derailment rates in the US at least have been stagnant or even perhaps slightly increasing. And that's not good when any industry is not making continuous process improvement on reducing safety issues. Second, I've noticed through my work on certain derailments in the past couple of years that the advent of precision scheduled railroading, or PSR, is changing the operating environment and landscape. And I want to point out some issues that I think we should be alert to as PSR takes hold at most all the railways now. We're not here to discuss whether PSR is good or bad. but I'm here to talk about some of the ramifications. And then third, I want to leave you with some thoughts on what I think we should be doing moving forward as we get into, as we try to reduce these derailments. I got to read you a disclaimer here that the ideas presented here and opinions are mine alone. They do not represent those of the University of Illinois, Major League Baseball, or hardly anyone else for that matter. In fact, some may find that these views are iconoclastic, a bit too critical, or offensive. But folks, sometimes tough love is required to effect long-lasting change and improvement. These views are presented in the hope of moving the needle downward on derailments in the coming years. And if your feathers are easily ruffled, you may want to tune out or go watch the Masters, which is teeing off about now. Okay, with that out of the way, as I said, the outline is we're going to discuss where we stand in our industry in terms of the derailment numbers and rates. I'm going to talk about the impact of changes in the PSR operating environment and the potential effects on derailment rates. Not that every one is going to have an effect. Third, the role of railroads, the FRA, and the investigative agencies in moving the needle downward in this critical area of derailment prevention. And lastly, as I said, some suggested strategic changes and tactical changes required to move the needle downward. Okay, so where are we? This is a chart of all FRA reportable derailments, does not include Canada, just USA FRA numbers, from 1975 when I started in this business up until last year. And as you can see, it's a pretty interesting line here. Back in the 70s, early 80s, we were having 6,000 to 7,000 reportables a year. With the advent of the Staggers Act and deregulation and substantial investment into the rail industry, along with technology improvements, some excellent work of the Track Train Dynamics group, sponsored by the AAR, and which morphed into the Vehicle Track Systems group. All that effort, corroborative effort of all the Class 1 railroads at the time, drove these derailment numbers down in the 2000 range, entering the 1980s and 90s. And then we had another peak that started upward in the mid to late 90s, which I think may be driven by a couple things. That was the advent of 286K and 315K car loadings and some of our struggles with those, as well as the general increase in traffic. Railway traffic tended to peak about 2006, and I'm not sure in terms of carloads if we're back to that level or not. But then with the advent of more detectors, more regulations and changes in traffic, we brought those numbers down again into around 2010. And for the last 10 or 11 years, we've been hovering around 1,200, 1,300 reportables a year. And currently a reportable is about $11,000 in cost, which is only track signal and equipment. If you break that down in terms of the rate per million train miles, we see a similar trend since 2000 here. I'm zooming in on the last several years now, last 20 years. But on a basis of rate per million train miles, which sort of takes traffic changes out of the picture, we see the same trend of a flat line and possibly an increasing line in the last couple years. And we're somewhere around close to 3 derailments per million train miles right now as an industry. And my goal, I'd like to see that number come down to 1.0 or lower, and I think we can achieve that. If you're interested in how the derailment causes break out by the various operating groups, this shows the red line are the number of track derailments. The blue line at the bottom is the number of equipment derailments. And then in the middle, we have the green line, which are called the human factor or human failure derailments. And you can see that for the last 30 years, roughly, human factor derailments have also been a flat line. With all the changes in technologies, all the simulators we're using, all the certification programs, better training programs, better equipment, we're still seeing essentially a flat line in our human factor derailments. So again, zooming in on the annual total derailments for the last 10 years or 20 years, I should say, from about 2009 or 10, we've been experiencing roughly 3 to 4 reportables a day in our country, or 12 to 1,300 a year. And I make a note there that last year, 2020, was COVID-19 year. And I think that affected a lot of things, which makes the numbers less than statistically relevant because of the tremendous drop in traffic and furloughs of employees and parking locomotives and all the bad stuff that happened under COVID. And as you can see, again, it's pretty much a flat line if you tried to do a regression on it. Now, I'm throwing in on top of our derailment numbers in green, a red line, which is our derailment costs. And these are the track and equipment costs that we've incurred year by year. And you can see, even though derailments have been a flat line in terms of numbers, the costs have quite a bit of variance in them. And that's another, not a good thing, certainly for an industry who sees widely changing cost numbers. And there can be reasons for these, a number of severe derailments one year versus another. But that is not a good trend when your costs are changing quite dramatically. And it does portend a process slightly out of control. This chart highlights, again, back to strictly human factor derailments, which I'll have more to say about later. But we look for the last 20 years, the green line shows a number. And the red line shows the cost values associated with the right-hand axis in millions. And you see the same thing, that human factor accidents have widely varying cost numbers associated with them. And I don't think that's a good trend at all. If you're interested by the 5 big buckets of FRA data, we have equipment costs on the far left bar. This is both number of derailments, and the line is the expenses. You see the human factors are way over 10,000 for the last 20-some years. Miscellaneous causes, which I'll have more to say about that. I don't even think we should have that bucket, to be honest with you, but that's a substantial number. Signals are the smallest, thank God. And then track-related derailments are the largest grouping of derailments. And here's some data obtained from the AAR website. And this includes train accidents, which includes collisions and other kinds of things. I've been talking strictly about derailments up until this point, isolating out collisions and other type of accidents. But this chart shows train accidents, it shows grade crossings, it shows injury cases. And again, you can see all of them are pretty much a flat line for the last 10 years, which, and not only flat line, it may show some, again, some creeping up or increasing trend going on here. And no industry wants to see accidents and derailments moving in the upward direction. And bear in mind that these track and equipment costs that I've been showing you do not typically include the re-railing and cleanup costs to bring in groups like corpsmen or Halter. They don't include lading damage, and interesting enough, trailers and containers are considered lading. And when we dump a container train on its side carrying high-value commodities, the cost can be quite high. It typically doesn't include environmental cleanup or long-term damage. And here's another important bullet. The fourth one is the opportunity cost of taking tracks out of service and loss of network reliability, which impacts car hire, crew costs, locomotive costs, and train delay penalties, which are real dollars today. Many railroads are guaranteeing, especially in the intermodal markets, guaranteeing service levels. And if they don't meet the arrival times, they might have to pay penalties. So this is real dollars. Litigation cost can be out the window on major accidents, injuries, fatalities, evacuations. Public relations costs are very hard to quantify, but it does give our industry a black eye when you see a train exploding on CNN or Fox News. Also cost to get to derailment sites and damaging of adjacent landowners' property. So Since 2000, I've added up the numbers, and just on track and equipment, we spent roughly $5 billion on derailments. And if we factor in all these other ancillary costs, the actual total may be closer to a $10 billion price tag for our industry. And think what that could buy us in terms of track structure, equipment, locomotives, and things of that nature. The inconvenient truth is that derailment costs can vary widely based on speed of the train, the commodity you're carrying, and the location. It's one thing to derail maybe in the middle of Nebraska, no offense to the Cornhuskers, but derailing out in the plains of Nebraska might be different than derailing along a navigable waterway in terms of environmental impacts. For instance, the Lock-Meganic derailment, which took, I think, 48 lives and essentially ruined an entire city in Canada, is estimated to have cost roughly $3 billion to rebuild the whole town's infrastructure. But we probably would have never heard of Lock-Meganic if the train was carrying frac sand or corn or gravel. So that's the whole business of where you derail, what you derail, and what's the speed of the derailment. Now let's talk about the PSR environment and potential effects that I see it could have on derailments. And again, we're not here to discuss the merits of PSR. It is here, it's here and now, and just about every railroad is embracing parts or all of it. And so we're not here to discuss that issue. So here we are, we've got PSR, we've got PTC, we've got CV19 and WTF. And for you, those of you who don't know what that means, it's where's the freight? We've had some changes in our freight mix, you might say. Here's carload freights in 2019 is in green. 2020 in blue is the COVID year, which we had substantial drops in traffic. And this is carload freight, not counting intermodal. And then we're starting out this year in red there. We took a significant hit back in February, March. Traffic dipped considerably, and a lot of talk is that was the effects of weather-related issues. But again, I don't know that our industry's ever taken such a severe hit in traffic over weather. We've had cold weather in America for 200 years now. But it may have something to say about the effects of PSR and the maybe inability to recover under certain conditions. This shows just coal traffic, and I'm sure most of you know the picture there. Coal is gone, it's going, and it probably won't come back. And that was 10 years ago, 40% of railroad revenue was coal. And you see the green line is 19, the blue line is 20, and 21 in red. And so we're also seeing a whole shift in the coal market and the revenue stream from coal. And the question is, if these car loadings continue to drop and revenue slides, will we have the funds available for maintenance of our infrastructure and reinvestment back into our infrastructure? Now, some of the tenets of PSR, and I just threw them all up here because many of you know about precision scheduled railroading, but some of the principles of it is to have less touches per car, less switching, more destination blocking, a focus on car performance rather than train performance, focus on car and train velocity and less terminal dwell time, minimizing unit trains, optimizing the entire network and not just single divisions or terminals. We used to do a lot of that back in the day where trains out of towns.
Gary, I think we've lost your audio if you can hear me, and your video. Maybe turn your video off and let's see.
How's that? Am I back?
Can hear you. Yep, we can hear you loud and clear now. So we lost about the last 2 minutes or so on tenets of PSR.
You want me to go back up a slide?
No, I think we lost you about a third of the way through this slide.
Oh.
And now we can hear you loud and clear now.
Okay, everything back to normal, Riley?
Yep, sounds good. Thank you, sir.
Okay, well, I was just going over some of the tenets of PSR here and talking about we're changing tonnage of trains. Trains are getting longer, trying to run more on schedules with more predictability. We're doing more flat yard switching, and we're trying to drive decision making down to local levels, which is reducing bureaucracy and staffing at headquarters and things like that. So to summarize, with precision scheduled railroading, we will see a change in train lengths, both plus and minus, meaning maybe longer trains, maybe shorter trains, and speeds, meaning maybe some trains will be going faster and some are going slower. We're going to see a change in traffic mix with less reliance on coal and other commodities, and certainly a more heavy growth in the intermodal market, which indicates or usually results in faster trains. And basically, PSR is doing more with less. And we're seeing that across the landscape with fewer locomotives, many locomotives being in storage now, fewer crews, less staffing at headquarters, fewer cars, less yards, and less track were not needed. And what that means is that higher utilization of assets, doing more with less, means you're going to have accelerated degradation of those assets. Cars, the wheels will wear out faster, the locomotives will wear out faster, and we can't ignore the facts on the human element as well. We may be stressing the human element with some of these changes. Some potential impacts of PSR on derailments, specifically, number one here is curve elevation issues. Higher car velocity, if we run shorter trains, more frequent trains, may increase speeds on curves, which results in insufficient elevation. And then if we're going to start running longer trains, it may require slower operations on certain portions of the track, and we might end up with excessive elevations in curves. And under or over elevated curves has a pronounced effect on rail grinding, the development of rolling contact fatigue, rail lubrication issues, etc. So we got to really take a hard look at curve elevations. With higher speed trains, we may have more truck hunting, which does wear out the track structure, particularly on tangent track. It causes wide gauge. And as we change from slow coal and ore trains to fast intermodal trains, again, we may see more hunting activity, and that tends to wear out equipment at an accelerated rate. Changes in train blocking. We're seeing trains being blocked more to destination rather than with regard to maybe dynamic effects in train forces, which can create more slack action, which may again put more wear and tear on both the track and equipment structure. When you have a 200,000 or 300,000 pound running in a train, those forces don't dissipate into midair. They manifest themselves at the wheel rail interface, and it affects track structure and equipment. And certainly with longer trains, you're going to have typically heavier drawbar forces. Now, some of this can be mitigated with distributed power, and many railroads are doing that, but I'm just laying out potentials here. I'm not saying these are certain. Longer trains put more heat in the rail. I don't know if many people realize it, but as the train goes through a 9 or 10 degree curve, every wheel is producing friction. Friction is heat. If you're sitting there in the summer with rail at a temperature of 125 or 130, and here comes a 200 car train around the curve, you may add 5, 7, 8, 9 degrees of heat to that rail, and which could increase the buckling probabilities. And then also our lubrication systems. The longer trains you run through a curve, the more lubricant you will eat up, and we may have to be looking at our retention and carry forward rates on lubrication. Longer trains mean more horsepower, which will affect rail anchoring. When I started railroading, we put 5 SDs on a train, and that'd take up 300 some feet of real estate under the train. Today, 2 high adhesion locomotives can do about the same work with a footprint of only 140 feet. And that puts a lot of stress on our anchor patterns, which is important, again, in the war against track buckles. And then larger drawbar forces create more lateral force in curves, oftentimes. again, resulting in more wear and tear, more plate cutting, rail cant, things of that. And we know longer trains, especially in the winter, results in more brake problems, sticking brakes, flat wheels, wheel impacts. And then longer, faster trains, which is all good, but potentially will result in bigger derailments when they occur. Remember that derailment severity is due principally to tonnage and speed. So we got to look at that aspect. Something else I've been hearing in my travels around the industry is that maintenance people are having a harder time getting track windows to do maintenance because dispatchers have been told don't screw up the schedule. And so, you know, when a track inspector has to get on for his weekly inspection, or you've got to do some curve patch, or got to do some Sperry rail plug rail change outs, seems like it's getting harder and harder to get those track maintenance windows. And then a few other things here, increased switching volume in flat yards. A lot of our flat yards were maybe not maintained to the same standards as hump yards, and we're putting a lot more traffic in our flat yards, which is going to have to increase our maintenance focus on turnouts and yard leads and things like that with more kicking cars and flat yards. Fewer crews. The question is, how about the human fatigue factor? Another thing on the horizon, I would say, are single man crews, maybe with a conductor chasing in a car beside the train. And what's the effect of that? Less management to handle exceptions, less bench strength. You know, I mentioned when we had that dip in February, it seemed we had a hard time dealing with the weather. And it used to be when we had issues in a certain area of railroad, you could send a team of headquarter people out there to maybe help mitigate the problem. But now we ain't got any bench strength left at the headquarter level. And it's just like a football or basketball team. You're going to have injuries, you're going to have people in foul trouble, and you're going to need to bring some bench players in. And I sometimes wonder if we have the bench strength that we used to have. And with derailments now and the schedule, the pressure on schedules, I've noticed and I've been hearing about it, an emphasis on getting the track open, which is all well and good, but that also affects your ability to properly investigate derailments. So these are some of the potential impacts. And again, these are potential. I got to emphasize that. I'm not saying PSR is going to cause all this, but it's things we've got to think about. So PSR and derailments, what's the bottom line? Or WTBD, what's the big deal here? Well, the big deal is that operating precision and reliability cannot coexist with derailments, disruptions, slow orders, signal malfunctions, and human failure. Just can't happen, folks. To operate a precision network, we must eliminate disruptions, outages, and especially derailments. They just don't go hand in hand. So I think we ought to look at a new PSR goal, and certainly an operating ratio of 60% is great and wonderful. But how about a new goal of 1.0 derailments per million train miles? And can we get there? And I think we can. And what is needed and who are the stakeholders? Well, here's my derailment reduction prevention trinity. I think the railroads have a very large role, obviously, but we can't ignore the impact of the regulators, the FRA, Transport Canada, and on the equipment side, the AAR. And over here on the left, the investigative agencies like NTSB and TSB also, in their efforts, direct our research as to what are the critical factors. And as everyone knows, the NTSB has particularly been pushing for PTC for 20 or so years, and PTC is here and now, and that's now a thing of the past. But we got to move our look forward onto new horizons. So to the railroads, I think number one, we have to assign corporate ownership to derailment prevention. Somebody must own the process, and you can't say or hide behind the fact that it's everyone's job, because then it falls through the cracks. We need a leader, a mentor, a champion on every railroad property that really owns derailment prevention. And without that, a lot of things tend to fall through the cracks. We need better training in derailment cause finding. I've been doing a lot of training the last couple of years, and There's just a tremendous number of new faces in our industry, some with very limited experience in derailment cause finding issues, and even the old heads in the business need to be brought up to date on what research and technology has taught us about derailment causation. We need to use or make better use of big data coming from the operating network to spot trends and conditions. And I know Mr. Zaremski and the University of Delaware has held a number of conferences on big data, but railroads are collecting gigs and gigs of data every hour, and how they use that remains to be seen in all cases. But we really need to start using this data to look at trends in derailment and accident prevention. We need to continue our application and deployment of automated detector systems, things like drones, on-track vehicles, like I heard about yesterday on the Railway Track Instructors webcast on track and fastening using the Georgetown automated tie inspection system, things like that. Wayside detectors, onboard systems, autonomous, and the Internet of Things are, again, here and now, and we need to really take advantage of this technology, linking these detectors into meaningful action items. We need to provide adequate time and resources for derailment investigation. I continually get phone calls when people ask my help on a derailment investigation. I hear the familiar refrain is, Gary, they just won't give us time to do it. They want an answer in 12 hours. And sometimes derailments take a couple days to really sort out all the issues. So management needs to give the field personnel time to make a good investigation. Our corrective actions that we put in place, we need to follow up, make sure they're working, and that we don't get any unintended consequences. And folks, this is a big one. We need a much greater emphasis on understanding and eliminating human factor derailments. I showed you the flat line, and when you think about it, human failure should be the easiest one to reduce. I mean, to change the track structure takes money, change equipment takes money, big dollars. But just simply changing human behavior shouldn't be that capital intensive. I'm not saying it's easy by any means, but we need to focus on it. And in that, also kind of connected, or a corollary of that, is we need to revise our rules and instructions for greater clarity and less ambiguity. I bet a week doesn't go by when I'm presented with an accident involving rule violations or something, and people start asking questions about what this or that rule really means and how it's supposed to be applied. And we shouldn't have to do that. If we use terms and rules, they ought to be defined. So that's just another thing. Now, to the regulators, and that'd be principally FRA and AAR groups that set our regulations in our industry. As most of you know, our track standards are largely set by the FRA, and our mechanical standards are largely dictated by the AAR interchange rules. And these are not meant to be, specific criticisms, but my observations of where we need to go with regulatory actions. First, we need to ensure regulations are keeping pace with technology and infrastructure improvements. I've watched so many products be introduced to the rail industry, and they're being used and deployed all over the place, and yet we have no regulations. People don't know how to measure them, don't know how to inspect them, etc. We need to make sure that's keeping current. We need to rewrite, update, reconsider, or simplify some of the sections on 49 CFR. It's gotten very unwieldy. We keep loading more and more in there without really going back and integrating and revising. I think it's time to consider revamping all the derailment cause codes. These cause codes have probably been around for 40 or 50 years. We need less ambiguity and more specificity. We need to reduce the number of miscellaneous cause codes. When any industry attributes 13 or 15% of its accidents to miscellaneous causes, that's not good. And we need to minimize the allowance or use of the words cause not found. Special emphasis needs to be done on revising our human factor cause codes and move away from descriptions to the why. For instance, a switch run through, which is an FRA cause code, it tells you what happened. It's a description of what happened, but it doesn't tell you why the switch was run through. And I'll say a few more words about that as we go along. And I think the FRA needs to follow up on the causes that are being turned in to ensure there is sufficient supporting data for the stated cause and ensure that accurate causes are entered into the database. I would challenge any of you to go into the FRA database and go take the month of last December or last November and look at the causes, the narratives, and then look at the causes and see if it makes sense to you. But the problem is we focus research money and projects on where these cause codes telling us the problems are. And if the cause codes are masking real problems, we're not focusing research on what we need to. So what about keeping pace with technology? Well, here's just a few minor examples. Concrete ties started being used in the 1980s. It wasn't until around 2005, I think, that the FRA issued regulations concerning the inspection of concrete ties. Constant contact side bearings started being used in the 60s and 70s. We still don't have a federal regulation under 215 or 231, and it took the AR until about 2006 to add constant contact side bearings to Rule 62. CWR rail started in the 50s and 60s. When did FRA issue regulations? 99. It was the first round of where railroads had to submit a plan to manage CWR. Event recorders started in the 70s, and first regulations came out in 92, almost 30 years later. Plastic center bolt liners started back in the 70s and 80s, and I think the first mention I saw of non-metallic liners in the AR regs was 2012. So these are just a few examples where regulations need to be keeping pace with the implementation of technologies. All right, rewrite or consider or simplifying some sections of 49 CFR. On the top is the 213 Track Safety Standards book, small handbook. On the left is the 213 Compliance Manual, 8.5 by 11. And I'm not critical of it. It's an excellent compliance manual. David Casticelli and his group have put together a wonderful manual to help people interpret the 213 book. But anytime it takes that much paper to tell you what that little handbook says, you got to wonder if the handbook is written in total clarity or not. And then at the bottom is simply a picture of our Title 49, which includes all the railroad regulations in 1981, which is roughly 500 pages. And here we are in the last copy I had was 2018, but it's over 1,200 pages. And we've added many new sections without going back, revising, etc. Okay, what about the derailment cause codes? Let me get to that. First of all, if you did a pie chart of all the causes, this is like last time I did this was 2014, 15, 16. I threw all the causes in a big bucket and made a pie chart. Well, about a third are human, a third are track. But then we got this blue bar called miscellaneous, 13%. And I just don't think we need that many causes attributed to miscellaneous. And in fact, when you get down to a lot of stuff that ends up in miscellaneous is probably more related to human failure or equipment. So that's something to consider. And then just on some of the cause codes that I think are antiquated, like up here in the upper left, they've got two cause codes: truck bolster stiff, failure to slew, that's one code. Truck bolster stiff, improper swiveling, that's another cause code. Well, I don't know what the hell's the difference between swiveling and slewing, but we got two cause codes, and none of them are really causes, they're effects. Okay, a stiff truck is an effect of poor maintenance, such as tight side bearings, bowl rim clearance, center bowl wear, etc. And then the other one, truck hunting. Truck hunting is a condition, not a failure mode. Truck hunting results due to hollow-worn wheels, insufficient side bearing restraint, poor friction damping, wedge rise, maybe violating speed restrictions. But to say a car was hunting doesn't tell you why or what needs to be fixed. On the track side, we've got track alignment irregular, T109, buckled or sun king. Folks, there's 7 or 8 reasons why track kinks in the summer, okay? But just calling it a track buckle doesn't lead us to corrective actions, doesn't tell us what we need to research. You know, track buckle can be due to poor anchoring, worn out anchors, poor ballast quality or section, poor neutral temperature control, improper lane temperatures, geometry irregularities, foul ballast, etc. And so the cause codes don't lead us to corrective actions. They don't lead us to tell us where the problems are. They're just putting a description on things. And here's the human factor cause codes, which I think we need to move from these descriptions to the why. Why do they happen? Now, here's just a sampling of general switching rules: cars left foul, run over derail, failure to couple, etc. These are cause codes. They describe what happened, but they don't provide any information as to why the human failure occurred. And as an industry, both at the regulatory side and the railroad side, and even at the NTSB side, we are not drilling down to why human failures are occurring. We're simply putting a name on it and walking away from it, using terms like loss of situational awareness or head up the rear or other things more provocative than that, perhaps. And I think the FRA needs to follow up on these causes to ensure that the supporting data for the stated cause is correct and that accurate causes and information is entered into our database, which again drives much of our funded research. Now, I tell you what, I'm going to, just in the interest of time, skip a few of these, but here's an example here on slide 43. It says down at the bottom, and I've taken the name of the railroad and the location off of this, it says, employee failed to properly latch down the switch handle. As the train went over, the points began to float, derailing the train. And then up under the heavy red line, the cause was switch out of adjustment due to insufficient rail anchoring. All right, someone's got to read that and call the railroad up and say, hey, wait a minute, this looks like a human failure to me, but you're blaming it on track. And so what we get is a track-related derailment in the database, and we kind of gloss over the human failure here. So how does a human failure description morph into a track cause of insufficient rail anchoring? It's beyond my understanding for sure. Here's one where it says train northbound and so coming at the mill, talk about this speed and that speed, and the cause was put down as speed. The problem is, how did speed cause the derailment? What was the speed? What was the speed limit? Why did the overspeed occur? I think someone should call this railroad up and say, well, what exactly are you saying here, and how did speed cause this derailment? What's this one? Train makeup. Yeah, they gave this narrative about how the wheel popped off the track while sitting still. Well, last time I checked the laws of physics, that's pretty hard to do, folks. But yet in our database, that's what it got blamed on train makeup somehow. But there's no mention of car condition, track condition, or how the train makeup was improper. And folks, these are just from the last couple months of the FRA database. And this thing cost $250,000. And I don't know how the railroad knows what the heck to do to prevent the next one from occurring if a wheel just pops off while a train's sitting still. Restricted speed. Yeah, they said other truck component defects. And then at the top, the question is, what are the truck component defects? What do we fix? What do we put attention on? What should we be looking for at the next derailment? Just to blame it on this nebulous other truck component defects, again, is not helping the cause here. And here's a couple more. Well, this one I kind of like. This talks about a train coupled up and a train line trolley, air hose support broke. And then as the train pulled, it ran over it in a switch frog. And then the cause got put in here as objects or equipment fouling the track. Well, you see, here we go again. Object fouling track is one of those miscellaneous cause codes. It doesn't blame the track, doesn't blame the equipment or the human factor. Okay. But this seems to be a mechanical failure of equipment or possibly improper train handling. But yet we're putting it in the miscellaneous bucket without any real explanation. And this one was over 100,000. Now, on to the NTSB or TSB, the investigators that are charged with looking into these accidents, picking and choosing which ones, and keeping the railroad safe. We need to provide reports in a timely manner, certainly less than a year. because if you're going to affect corrective actions, you've got to do it while attention is still focused on the accident. Writing a report 3 years, 4 years after a derailment, most of the people have probably died and gone to heaven by the time the report gets published. And it's really going to have very minimal effect on corrective actions. We need more cooperation at the accident site. We need to work as a team and eliminate the us versus them attitude. And I bring this up from personal experience in the last 7 or 8 years of being at accident sites with NTSB people who are not cooperative. They're taking data from the scene. And this is my personal experience, all right? I'm not casting any blanket over everyone here, but there's just been a change in attitude. I've had great success working with the NTSB going back to the 80s and 90s and working cooperatively with them, but something's changed in the last 10 years where it's become a we versus you thing, and that's not helpful for anyone. NTSB has to quit listing human failure as a cause and explain why and how it occurred. They often use the term there was a loss of situational awareness, but that's not a cause, that's a description. And I think we need to utilize current research on human performance and attention awareness that's been pioneered by groups like Atticus Consulting, DECRA, and others, and is used extensively in other safety-sensitive industries like the aircraft business, nuclear industry, oil and gas industry, etc. We're not taking advantage. Those industries are learning how to reduce human failure. And we're rocking along with, as I said, a flat line for the last 10 years. We need to minimize the political inferences in the investigations and stick to nuts and bolts. And again, I don't want to get too deep here, but it's pretty apparent that sometimes politics plays a larger role than it should in some of these investigations. And we need to develop corrective actions and recommendations for both primary and contributory causes. Let's talk about my allegation of providing reports in a timely manner less than a year. Back in the 70s, I looked at the NTSB data log of when an accident happened versus when they made a report. And you can see here, you can read it on your own later, but roughly it was about a 13-month average from accident to final report. Here we are in the last couple of years. It's crept up to a 25-month average on average. Okay, that's over 2 years from the time of the accident to the final report. And as a very experienced investigator, I'll tell you this, I leave probably 80% of derailments, I leave the site with a pretty darn good idea of what happened. It might take another week or so of simulation work or metallurgical work to figure it all out. But there's no reason a derailment takes 2 years to write a report on. I just don't understand it. And it loses its meaning when it takes that long. Here's one that took over 5 years, Shepherdsville, Kentucky, from 07 to 12, 62 months to write a report. Here's one that took 4 years, and they came out with no cause found, or NTSB. And I'll make the point, every derailment has a cause, okay? And we've got to understand that. You can't walk away from a derailment. To move a wheel off a rail when there's 30,000 pounds of downward pressure on it, it takes some action. And to walk away and say we can't find a cause is like just not good. Now, let's turn to Canada. I got some kudos here. This is the TSB in Canada, and I just looked over their recent past, and they're averaging about 7 months between accident and final report. And I believe that's timely, and I believe you can do something with that. So kudos to the TSB in Canada, and I'll say something else. When you read the TSB reports, they're extremely thorough. You actually learn from them. And I encourage everyone on this webcast to go to the TSB website and look at their reports. You will learn so much about derailment causation and how a good derailment investigation should be handled. I mentioned listing human failure and loss of situational awareness. I'll show you one example here. NTSB determined that the probable cause was a ice and snow buildup derailed a boxcar on which an employee was riding, crushing the employee between the boxcar and an adjacent building. Contributing to the accident was a decision to ride the boxcar when conditions were not determined to be safe. Well, all well and good, but why did he ride the car on the side between the building? Why not on the outside of the car, as the rules call for? Did he have distractions? Was there job pressure? Was there a lack of a job briefing or improper job briefing about the risk of this movement? Were job steps interrupted? Did he get confused? Was there lack of rule knowledge? Was there rule violation? Were there close clearance signs present? Were they not observed? And why wasn't the ice and snow cleared? These are the questions that really drill down to the why of an accident, not just a description of what happened. And I'll skip over these couple slides in the interest of time here, but you can read them on your own. That calling things loss of situational awareness is not describing why accidents happen. So what has our derailment experience taught us? Well, we've learned that the current methods of condition assessment, that is individual measurements of track geometry, rail conditions, vehicles at discrete increments of either time or mileage, may not be sufficient to prevent all derailments. If it was, we wouldn't be having a lot of these different derailments. The current practice of periodic human track inspection and vehicle inspection is apparently not finding conditions that can lead to derailment. And simple compliance with standard may not always be enough to prevent accident causation. And why is that? Well, humans may not be capable of correlating all the conditions they observe and making connections of possible outcomes, of looking at track and trying to link it to a vehicle condition, etc. Human inspection is highly variable. It's based on skill, experience, and physical and mental conditions. I've got to say, even an A+ inspector has days when he feels like C or D, for various reasons. So there's a lot of variability in human inspection, whereas machine inspection is pretty much spot on day after day. The interval between geometry and vehicle measurements may be too long to catch rapidly developing conditions. Again, PSR, we're moving quicker in the PSR world, and maybe things degrade faster than they used to. And track inspections may not be taking into account the variability of vehicle conditions, wheel profiles, or operating speeds and drawbar forces that are now operating over that track. Things we used to get away with 20 years ago may have changed considerably in the last so many years. And finally, current management methods or techniques, our training, our rules testing, our job briefings are not providing continuous reductions of human factor derailments. If they were, we wouldn't see a flat line for the last 10 years. We wouldn't see 600 to 700 human factor accidents a year, or 2 a day, 1 to 2 a day, if everything we were doing is working. And I think we need to look in the mirror and ask some questions. Now, what are the strategic changes needed in the rail industry? I think we need to move from maintenance-based pass-fail regulations and change from reactive to proactive. Okay, meaning sometimes by the time we catch something, it's too late. We need to be doing more trending, more looking into the future. Prime example is the temperature trending we're doing on roller bearing heat, where we find bearings way before the failure occurs. We can do, it's here and now, it can be done, but nobody really wants to do it, but we can do performance-based derailment risk assessment based on actual track geometry measurements, taking into account the types of vehicles that may operate over that track, including vehicles with defects, the magnitude of drawbar forces in that region, and the speeds they may operate. And we can assess whether the track as measured can handle the types of trains and cars and vehicles and speeds and drawbar forces that are running on it. Autonomous and automated geometry and rail profile measurements should be performed frequently at time intervals commensurate with traffic conditions on the line. Again, we have to assess what we were doing 20 years ago may be different today. There's some routes now handling much more traffic than they did and vice versa. I would love to have an automated method to measure rail neutral temperature where we could go down the track on a high rail truck and know whether our neutral temperature was 95 or 65. I know we're making progress towards that end, but that's sort of a holy grail that we really need to look into. I'd like to update our track regulations and base them more on actual performance versus measured conditions. This should include combination conditions in the track instead of just discrete measurements. we know, and I know from experience of simulating many derailments, that technically the track met all the FRA standards, but in combination, maybe an alignment defect on top of a cross level defect was sufficient to put a wheel over the rail. We need regulatory incentives to move in these directions by relaxing some of these, again, antiquated, mandated, labor intensive and safety sensitive weekly, monthly, or mileage inspections. You know, is a 1,000-mile brake test still needed? Is a twice a week high rail trip still needed? And the fact we're running autonomous geometry cars every day. And we need to develop the dollar incentives for deployment of more premium trucks. Premium trucks are more forgiving of the track structure. They provide a much safer ride, but yet, you know, it's tough to get the way the investment works now. A car owner might say, why should I buy a premium truck when the railroad gets the benefits? And we need to try to make it a win-win for all the stakeholders. This continuous ultrasonic rail testing seems to be paying good dividends. We need to keep moving in that direction, I think, versus the stop and verify method. And also, it'd be great if we could automate turnout inspection. We have a lot of derailments and turnouts. And if we had a way to run a car or high rail truck or something through a turnout, measure guard check, guard face, guardrail clearance, do some kind of machine vision on the switch point, check switch point throw, all these things, that would be another great step forward. And again, I come back to our increasing our emphasis on why human failure occurs. Can we do it? Yep. Most of the technology exists. What is needed, though, is a cultural shift at both the railroad and regulatory level. We need a realization that new and different data may be needed in our measurements to really catch the incipient conditions leading to derailments. We need better data mining using big data to connect the dots in all the data we're collecting. And we have to understand that it's a collaborative effort between the vehicle, the track, and the operating department. It is a system out there. We need to change finders into fixers, and we need a business model that can prove the economic benefits of moving in these directions. How to start? We can start small with one division or territory, get buy-in from the various stakeholders like labor, regulators, and the departments, determine our success criteria, and make a business case for the investment. Now, the last thing I want to bring you, a couple slides, is that what I see are 12 tactical strategies. What I just gave you were strategic, overarching issues. These now boil down to what each railroad, I think, needs to be looking at strongly to get derailments under 1.0. First is to develop a corporate focus. Let someone in the corporation own derailment prevention, be accountable for derailments, focus the field resources on improper investigation, things like that. We need to develop, a railroad needs to develop a network of integrated and automated inspection and detection systems, whether it's wild sites or TPDs or wheel profile systems, machine vision, whatever. That's where the finding issues before they become catastrophes is where it's at. We need to leverage big data. You need to ensure correct curve elevations for every railroad division and district. I see a lot of miselevated curves out there in my various trips and inspections. We've got to understand we don't elevate for the timetable speed. We elevate for what trains are actually doing today. And if your curve elevations are incorrect, you're going to wear out your track. You're going to increase derailment risk. We need to manage the wheel rail interface. There's been lots said about that. Gordon Paczynski's ARM seminar each year focuses on wheel rail issues. It's a great conference, and we need to understand that it is a system between the wheel and the rail, and things like rail lubrication, rail grinding, control of rolling contact fatigue, prevention of micro cracks, shelling and spalling. These are all issues that every railroad needs to focus on. Speaking of that, we need to develop an effective rail lubrication program, especially for sites where you have a lot of rail wear. Most all railroads today are employing top of rail lubrication in conjunction with gauge face. But if your railroad does not have an effective rail lubrication program, you need to get one. There's tremendous savings, both in dollars of asset degradation and derailment prevention by properly lubricating the rail. We need to eliminate rail camp. That's the differential cutting of a tie plate into a cross tie, either concrete or wood, that cants the rail outward at a 1 to 2 to 3 degree angle. Every railroad needs to look at it because many of our wide gauge rollover derailments are caused by pre-existing rail cant. On the equipment side, the two big things I see are tight side bearings, insufficient setup height on constant contact side bearings, and excessive wedge rise in the cars. Those allow cars to behave dynamically very poorly, and we need to put a full court press on that. Number 9 is management of CWR and rail neutral temperature. I teach a lot about this, and I always tell people, right in December, that's in January, that's track buckle season. And people look at me like I'm crazy. But I tell them that the roots of a June or July track buckle start in December and January when it's very cold. We need to understand that and manage our neutral temperatures to be sure they're where they should be, in the 90s or wherever. This is a big one in the light of PSR. Number 10 is to develop train makeup rules and strategies so we can handle these longer trains without putting adverse dynamic forces into the equipment and track structure. Number 11, perform root cause analysis on human failures and change these descriptions into actual causes or turn them into the why. We do not understand why good people sometimes do bad things and run a train through an improperly thrown switch or run a train over a derail. We have to understand why these things are occurring. We have to apply some of the science of human performance that's out there and make use of it in our industry. And finally, we need to increase the focus on drainage and water management. Another big thing that I think has crept up on our industry is development. And when rain used to fall 30 or 40 years ago, there was an orchard there or a cornfield. And today it's a Walmart connected to a Bed Bath & Beyond, connected to a Holiday Inn Express, connected to a 400-unit condo complex. And when all that water hits those roofs or that parking lot, it's on our track structure in 10 minutes, not in 3 weeks. And we're seeing washouts. We're seeing a number of high-profile washout derailments. Many of the floods I see, they're all attributed to global warming. I think a lot of flooding is due to development. And the water runoff rates are so fast today than they were 50 years ago when, God gave us rivers and streams to handle it. But now we're exceeding the throughput capacity of many of our water carrying facilities. So we need to keep a full court press on that. Now, we're done. I'd like to dwell more or drill down on these 12 tactical items, but I've suggested to Riley Edwards that maybe we do this in part 2 if they'll have me back again, where we can spend time just on these last 12 items. There's a lot more detail that I think would be useful. And finally, I got a shameless commercial here. If you're not aware, I've just published in the last couple of months a 435-page complete field guide to modern derailment investigation. It's very thorough, full color, nearly 1,000 photos and diagrams, and a complete description of just about every type of derailment you can imagine. And what are the symptoms? What are the causes? What will you see when you walk up to that derailment? What will the equipment look like? What will the track structure? What will the marks show you? It is available at our website if you're so interested. It's a lot of people have given me very positive feedback on it, so I think it'd be a very useful tool as we move forward in this quest to bring our derailments under 1.0. So I thank you for your attention, and I know we ran a few minutes over, Riley, but if there's any questions, let's rock and roll on those.
Sounds good. Gary, great presentation, and thanks for being willing to field a few questions. I don't think we're going to get to all of these, but I'm going to try to get through some of them, and consider this your verbal invitation to come back and for part 2.
Thank you.
The first 2 questions they're under the header of distributed power. The first one is there some yet undiscovered limit to the weight and length of freight trains beyond which railroads will not be able to mitigate derailment risk? Railroads first encountered slinky forces with the Tropicana juice trains and IndyCar cushion underframes in the 70s. The FRA had a report about this 10 years ago. Is the recent movement toward mega trains, with distributed power, is this new operating territory that we should be delving deeper into?
Well, Counselor, that's a compound question. Let me break it down for you. First, mega trains, long trains. Distributed power is a great tool. I grew up on the Southern Railway with distributed power. We called it low control back then. I was surprised that many of the Western railroads did not embrace it as they do today. I'm a great believer in distributed power, and yes, you can run pretty long trains. I think Jack Trislett's on this call, former employee of mine, and we worked, as I believe, we worked on a train in Australia. It was a distributed power train. It was over 500 cars, as I recall. We did the simulations for that. So big trains can be done. You just got to do them correctly. And you just can't let bean counters throw together trains and say, here you go, run it. You have to do simulation work. You've got to analyze it. You got to make sure it's dynamically stable. But I think big trains, or as you call them, mega trains, can be done. The other question, though, is once you get these mega trains out there, you also have risk of coupler failures and things. And when you got a 4-mile long train that's in 2 pieces, that can sew your railroad up for 12 hours putting everything back together. So those are other issues that have to be dealt with. Now, the other question about the Tropicana train, the Tropicana train runs the orange juice up from Florida to the Northeast, and it does have what are called end-of-car cushions. And yes, there's limitations on EOC trains in general. I've done a lot of research on auto racks and other EOC trains. Steel coil is another one. And there are limits. When you get upwards of 70 to 80 cars in an EOC train, you start pushing the envelope of dynamic stability. And I think those have to be dealt with on an individual basis. If the questionnaire wants to send me an email, I might could address it further, but those are issues when you got EOCs. Next question.
And the next one, I'll tag onto that, and it's a subset of what I think you already touched on there, but are you aware of, do you agree that there's a need for a best practice guide to the use of DPs? We know the Western railroads adopted them differently than the Eastern roads. Are you aware of informal criteria in terms of the railroads?
You know, I mentioned to the Heavy Haul Association, I don't know, 7, 8 years ago to Scott Lovelace that we wrote that handbook for heavy haul, focusing on wheel rail stuff. But I said, you know, we should write a heavy haul handbook on operating parameters, operating practices to address just what you said, some of the best practices for distributed power. As the saying goes, there's no one cookie cutter for all situations. And I've worked on all kinds of studies on distributed power, putting it in the middle, putting it a third back, putting it 2/3 back, putting it on the rear. I'm not aware of any such handbook. I think it's a worthy topic for a handbook. But as I said earlier, DP is a way to go. It helps with air brake problems. It has a lot of benefits, and I think we're seeing, like CSX today is running a lot of DP. Probably 5, 10 years ago, I don't know if they ran any DP. So I think just about all the big 7 railroads are embracing it now, and we'll continue to see penetration of distributed power trains and longer trains as we move forward. Next.
Thanks, Gary. This question deals with the metrics we use for reporting derailments. Will longer trains as a result of PSR, with longer trains as a result of PSR, is MTM, million train miles, the appropriate metrics? That is, does a single derailment today represent the same number of, say, ton mile or car miles? Would this show a different trend in some of your slides, such as slide 6?
Yeah, that's a great point. Be interesting to study derailments per cars in the train, say. That'd be an interesting one to look at. It would be possible to do that with some of the data we have. Yeah, moving forward, that takes a little more thought. I don't want to say anything just off the top of my head, but I think derailments per million train miles is a pretty good and encompassing number, but there may be better ways. I think the point is well taken. We might want to start slicing this data down into greater fidelity and do some more statistical studies like that. Good idea. Next.
Taking into account the massive loss of in-house knowledge in recent years, as well as the long-standing problem of silos between different groups at the railroads, would it be helpful to migrate toward a management function that would specifically be responsible for the health of the wheel-rail interface? And how would this, do you think this would have an effect on track cause derailments? Positive effect.
Yeah, I think a great example of that was, I don't know if he's on here, but Norm Hooper at British Columbia Railway back in the early 2000s was put in the position of managing both the track and the equipment side of the railroad under his purview. And I think he made tremendous progress being able to do that. Right now, of course, in most railroads, there are two different silos, the equipment silo and the track silo, and never the twain shall meet, as they say. And I think two positions on the railway would be very good today. One would be director of reliability, which would encompass derailments and outages and separations and air brake problems and motor power failures under one roof. And then the other would be management of wheel rail interface. I think because it is a system, and we got to though figure out the financial incentives to make that happen with current budgeting and other schemes. It's, you know, who pays the bill and who gets the benefits, and that's paramount in you know, what we're looking at in the whole PSR world is I think how we really look at the economics of maintenance and the distribution, like rail lubrication. You know, the track guys go, why should I carry this grease around when the mechanical department gets longer wheel wear, or the operating department gets better fuel savings? And so we've got to quit this parochialism and finger pointing between the departments and start running a railway as an integrated system overall, and not just at the wheel rail interface, but looking at fuel, looking at everything would be ideal if we could do that. But you know, these are the things that are easier said than done. They sound great on paper, but back to the question, I think wheel rail interface is a job function that should maybe be under one person, and railway reliability is another job function. Next.
I'm going to end on this one, and it's going to be a different kind of nuts and bolts question. It's going to combine a few things that I've seen in the chat window. And Gary, you know, we've got quite a few students on here that are getting started in the rail domain. When you go out to a derailment site, how do you determine the point of derailment, and what are the first things that are going through your mind when you walk up to one of these locations where there's been a derailment? What are you thinking about?
Well, I'll tell you this. When you walk up to a derailment, it's usually chaos. Sometimes there's stuff on fire. Sometimes there's, you know, people running around, and everybody wants to grab your arm and start telling you what the cause is. And the first thing I tell people is not as gruff as it sounds, but I say, give me some private space here. Let me just look around. And what I do, I start crawling around and I let the derailment talk to me. I let the evidence start speaking. I start sketching out wheel marks. And I don't do it with any biases. I just try to understand the mechanisms. I'm trying to understand where the wheels went, where they left the rail, how they end up over there. And it takes peace and well, just peacefulness to sort of do that. You got to get away from the mayhem and the confusion and the screaming and the yelling in order to do it, and just seek some time to walk the derailment site from beginning to end and let all the factors sink in. And that leads me usually to the point of derailment, which is step number one in the investigation. If you don't establish the POD or point of derailment, you will never figure the derailment out, because the POD is where everything starts from. It's where your geometry measurements start from. It's the wheel action that starts from there, etc. So I say take time, disassociate yourself with the clearing activity, work safely, sketch out what you're seeing. There's a miracle that happens, and I can't explain it, but when I start sketching on a piece of paper, wheel marks and things and equipment, it starts connecting the dots for me in my brain. And that's a technique I found very useful. And then obviously photograph everything that you can because once those guys start moving stuff, you have lost evidence you will never again have. It's so important to get there quickly and document the final resting point of everything and the marks that they leave, the witness marks, before the derailment cleanup starts. Is that
Gary,
okay?
that's tremendous. Thanks for your insight, and thank you again. This was a tremendous presentation. I've had several questions in the questions window about, will the recording be posted? And the answer is yes, it will be on our website. And if Gary's okay with it, there'll also be a PDF of the slides, but we'll let him make sure that he's okay with that. If
Yeah, I sent you a PDF. I sent it to Emma earlier. She's got that.
So we're going to leave them. We temporarily took them down, but we'll make sure that it's back up there since you're okay with it. Great presentation. We look forward to talking to you again.
And if anyone has questions, my email is on this end slide here, so they can always call me or email me. I'll be happy to chat with them.
Gary, thanks so much. And one last announcement. We have another seminar next Friday from one of our good friends at KTH Royal Institute of Technology, Dr. Sebastian Stickel. And the title of that presentation is Wheel and Rail Maintenance Planning with Support of Digital Twins. So same time next Friday, watch for the email announcements. And again, Gary, thanks so much and have a great weekend, everyone.
Thank you.
Bye-bye.